So here are some options. This is a normal curve. Let's say is centered at 0. And it has it has mu 0, the mean 0, and sigma 1. And this is what I already talked about, but I never really mentioned it or never really graphed it. It's the z-score. And it's called the standard normal. Standard normal. So a graph like this, or a normal curve like this with mean 0 and standard deviation 1, it's what we call the standard normal. So this will be 1 and this will be -1. Of course, these are those inflection points, and of course between these two we have 68%. And then -2 and +2, and then of course -3 and +3. Now here, side by side, two graphs, or maybe superimposed, I would say. Both these two are centered at the same mean, as we see. But which one has a wider spread? The red or the blue? I know it's a silly question. Yes. So let's say this is sigma equals 2, and let's say this is sigma equals 1. So obviously, although they're both normal, although they're both bell-shaped, etc., etc., they both have all the characteristics, horizontal asymptote, inflection points, etc., etc. And what is also very important to remember is the area, because they represent probabilities. The area under the graph represents all these probabilities. This is area equals 1. This is area equals 1. Otherwise, it will not represent the probability density function. So the area under this is also 1. Okay, so now quickly, before we look at to answer these questions, again, it's symmetric about its mean. The mean of a median and the mode are equal. On page 2. Highest point occurs at x equals mu, of course. That's the highest point. Inflection points we talked about. The area is always 1. Half to the left is, so half here and half over there, left and right of mu. A horizontal asymptote, the empirical rule applies. So everything is clear. Now let's answer these 4 or 5 questions. So remember, I already wrote this and I said, please try to get used to it. And now we know what it means. What does this mean? It means the z is the standard normal curve. It's a little squiggle says the distribution is normal. Normal. The first number is always the mean, and the second number is always the standard deviation. So this is the mean, and this is the standard deviation. So now if I talk about in general about a normal random variable, and I put the notation here, and we have to get used to it, is this. I'm saying x is a normal random variable. And if I say, let's say 4, 1, I'm telling you that the mean is 4, and I'm telling you that the standard deviation is 1. Okay, keeping all this in mind, so if the mean increases, the graph moves to the, so if the mean increases, by increases means it's moved to the right. If the mean moves to the right, the graph of the function moves to the anyone?
The right?
Yes, because if the, remember what happens? We know that mu is not robust. If there is a higher observation here, it will pull the mean. Yes. What if the mean decreases? What if the mean decreases, meaning there is an observation that pulls it to the left, to the left of the mean? So if we get an outlier on this side, it will definitely pull the mean, and the graph will move to the left. What happens to the graph if the standard deviation increases? So what happens to the graph if the standard deviation increases? It will have more of what? More spread. It will have more spread, like this one, the blue one. What happens to the graph if the standard deviation decreases? The graph will be more compact. Area under the normal curve of a random variable represents those two things. The probability of someone to be selected between such and such. We're going to look at examples in a minute. Or the chances of the sample size or the next observation to be found in that particular area. Okay, let's look at examples. You will see. I think that you're going to find this this section probably the easiest. Okay, example 2. And we're going to look at StatCrunch. I hope you have it up. I have it up in the background somewhere. Example 2, we are on page 3. It says the serum total cholesterol for males 20 to 29 years old is approximately normally distributed with mean of 180 and a standard deviation of 36.2. Based on the data such and such. Draw a normal curve with the parameters labeled. Excellent. That's our first question. The mean is 180. I'm going to say this is my 180. It has to have a peak at that point, and the standard deviation is so mu, and standard deviation is 36.2. That's the normal curve. What does this mean? It means that this side should be 50% and this side should be 50%. 50% of the observations are higher than 180, 50% are lower than 180. Okay, so we did part A. Part B, an individual with total cholesterol greater than 200 is considered to have high cholesterol. State the region under the normal curve to the right of x equals 200. Fine. So I don't have units here. I didn't, but let's say this will be 200. So the area to the right of 200 is the area that gives us the probability. So this probability for x to be greater than 180, the same thing with greater than or equal to, because we know at this point is 0. So you can write or the probability for x greater than or equal to 180, they mean the same thing because it's a continuous random variable. Is this area. So the probability for someone to have a cholesterol level greater than 200 is this area. Selecting someone, or the probability of selecting someone with a cholesterol level over 200 is this area as well. How do I determine this area? First, let's do the graphing calculator. And we go to second and distributions. We do not use the normal PDF. We use the normal CDF, cumulative density function. Normal, it's number 2. So second and distributions, right here, variables. So we choose the normal CDF. Press enter. The calculator is requiring us to put the lower limit first. The lower limit means in our case, we want to determine this probability. It's 200. So put 200. Then the upper limit So if you remember, we said this will be roughly in negative infinity and this way positive infinity. How do we present that in the calculator? So we write negative E99 for negative infinity and E99 for positive infinity. Where do I find this? Okay, right here. So go to upper. You may not have this kind of calculator. I'll show you. It's the same thing. So see this key with second and EE and 99. Second, the comma. Second and comma, 99. That's the upper all the way to the end. Now it's asking us to put the mean, which is 180. It's asking us to put the standard deviation, which is 36.2. And now I calculate. So even if you don't have this kind of calculator, you have an older model, that's fine. You still have the same thing. You have to write 200, comma, E99, comma, 180, comma, 36.2, and I press enter. So this graph, it's not really represented. I have a bigger area, so I should re-graph it, but it doesn't matter for this moment. So this is 0.2903. So the probability for x to be greater than or equal to 200. Why did I write 180? Please correct that. I'm sorry. It's 200. Well, I know the area greater than 180 is 0.5. I don't have to calculate that. That's very clear. So if I want the area to the right of 180, I get 0.5. I want the area to the right of 200. So that's why I have 0.2903, and I'll show you in StatCrunch how to do this in a minute. Okay. Suppose that the area, which we already did, is 0.2903. Provide two interpretations of this result. So from the study, so first interpretation, from the study, 29.03% had cholesterol level greater than 200. Two, another interpretation of the same area. Randomly selecting I think it was male from 20 to 29, a male from 20 to 29 years young. The chances are that he has cholesterol level greater than 200. The chances are 29.03% that he has cholesterol level greater than 200, full stop. These are the two interpretations. From the study, 29% of all of them had cholesterol level over 200. And if I select randomly a male, that person has 29.03 chances that his cholesterol is higher than 200. These are the two interpretations. Okay, so moving on. Any questions for me? Any questions? Okay, moving on. Okay, back to the same thing. We have the same, everything the same. Sorry. This was my page 3. Oh, yeah. sorry, I'm right here. So we're starting 7.2, which is applications of normal distribution. And there is nothing new here. I just want to graph it again and just remind you of the standard normal. Nothing new. I just already graphed this. I didn't wait till this point. So this is mu equals 0, standard deviation equals 1, and this is the standard normal. And we remember that the standard normal is calculated like this for each entry. Of course, this could be the sample mean, and this could be the standard deviation of the sample. And this is every entry. But we remember from now on, and we knew that already, that Z is normal, and the distribution has mean 0 and standard deviation 1. Okay, moving on. And here we want to answer several questions. And we have, so we're looking at kids, girls 3 years old. They are female patients of a pediatrician, and the heights are approximately normally distributed. That's our problem now. So the height, it's a random variable which is normally distributed, and they're telling us that 38.72 is the mean and 3.17 is the standard deviation. Use the normal model to determine the proportion of 3-year-old females who have a height less than 35. Okay, here's the graph. As you see, my normal curves go further away from the normal. Okay, sorry about that. Okay.